the vector form of Newton's law of gravitation. So what we have F is equal to G m1 m2 by r square, correct? Now if we are looking at the vector form, we have two masses m1 and m2. Now first thing, we'll consider the force on m2 due to m1. Okay, so I'll repeat this. This is force on m2 due to m1. Alright, so see, you have two masses m1 and m2. Right, the distance will remember these are central forces, that is the force is acting between two centers. So the distance, we'll call it as r21. Okay, so we have F21 is equal to G m1 m2 by r21 square. Right, so r21 square. Now we'll consider this to be r or r21, anything. Now the vector form we are looking at, correct? Now vector form, if we have to calculate, that becomes F21 vector is equal to G m1 m2 divided by r cube into vector r. So vector r gives us the direction in which the force is going. That is, here we are looking at force on m2 due to m1. Right? This is F21. Now similar way, the force on m1 due to m2, this will be F12, which is G m1 m2 divided by r12 square. Now if you look at it, the distance between the two centers is the same, but what is changing? The direction, correct? First is from m1 to m2, second is from m2 to m1. Now if you consider the vector form, r21 vector will be negative of r12 vector, correct? Or r12 vector is negative of r21 vector. So here F12 becomes minus G m1 m2 divided by r12 cube into vector r12. Right? Now here the distance is the same. So F21 will be the same as minus F12. Right? So this confirms Newton's third law. That is, if there are two forces acting, the forces are equal and opposite. Right? So between two masses of m1 and m2, so we have force acting along the center, which is F is equal to G m1 m2 by r square. Whenever we write the vector form, force on m2 due to m1 and force on m1 due to m2, magnitude wise they are the same, but we get a negative sign because they are in the opposite direction. Fine. So this is the vector form of gravitational motion, or gravitational law you can say, which is F is equal to G m1 m2 by r cube into vector r. Alright. Now this also confirms Newton's third law of motion, that is, forces are equal and opposite to each other. Alright. Now using this vector law, vector form, we can also do superposition. That is, if multiple gravitational forces are acting on the body, like what happens in regular day-to-day life. Like for Earth, if you consider, there is gravitational pull by Sun and even by other planets also. So it won't be just Sun. So here multiple gravitational forces are acting. So in such a scenario, we have principle of superposition. Okay. So what we get is F is equal to sigma. Now G is constant, so you can take it outside. So we get F is equal to G sigma I is equal to 1 to n, J is equal to 1 to n, mi mj divided by rij square into rij vector form or rij cap. So this is the normal form. If I have to do the same thing in vector form, then we'll get vector F is equal to G into sigma I is equal to 1 to n, sigma j is equal to 1 to n, mi mj divided by rij cube into rij vector. So this is what we call as superposition of gravitational forces. Okay, so one is the vector form, which is F equals to G m1 m2 by r cube into r, vector r. Another one is the superposition. Fine. These are the two important formulas.